So this beast of an integral looks quite intimidating, but it does not matter for us because we will be able to work through it together, I promise. So first of all, I'd like to call this integral I for reference purposes, and I'll make myself a u sub. My u sub is gonna be 1 over x being equal to u. That will make my dx be negative 1 over u squared du, and as to the bounds, whenever x goes to 0 from above, the lower bound, u is gonna go to positive infinity. Whenever x goes to infinity, u goes to 0. So my integral becomes an integral from infinity to 0, quite weirdly, of u to negative 1 to the power of negative natural log of 1 over u times the arctangent of 1 over u all over the reciprocal of u times the new du, which is negative 1 over u squared du. But now I can use that negative sign in front of the du to flip those bounds of integration so they, well, don't look as weirdly as they do now. Now, how can I simplify this integral further? Well, this exponent of u to negative first power, this negative natural log of 1 over u, I can say it's all just natural log of u because this negative sign can be interpreted as just the exponent of 1 over u, and 1 over u to the negative first power is just u. Now just multiply those exponents through to get u to the negative natural log of u power. This arctangent, I can't really do anything with it, so I'll leave it. Then I can distribute that 1 over u squared across the integrand to get rid of the 1 over u in the denominator. Well, I'm getting somewhere here. I mean, I got the integral from 0 to infinity of u to the negative natural log of u power times the arctangent of 1 over u all over u du. This looks quite a bit like the integral that I started with at the very beginning. I mean, quite honestly looks like the I. The only problem is that, or maybe the only two problems are that I'm integrating respect to u here and I, well, don't have a single x there, and that the argument of the arctangent became the reciprocal of the variable that I'm integrating respect to, yeah? But those two are not very hard problems to solve. So first of all, I know that this integral is definite. It gives me a numerical value and not a class of antiderivative functions or anything like that. I can just rename my variable as I please. I mean, I can call it x, y, u, t, theta, whatever I wish to, because it will not change the value I'm gonna get eventually after calculating this integral. So I can just replace that u with x. Awesome. And as for this arctangent, I leave it like that now. I leave it like it is right now. Awesome. And now I'd like to add myself those two integrals together. I'd like to add myself the I and the new integral in terms of x that I just, well, created here. They are both equal to I. So when I add them together, I will get 2 times I be equal to the sum of those integrals. But because they are, well, on the same bounds, I mean, in the same interval, yeah, I can just add those integrands together. I'm gonna get the integral from 0 to infinity of those two integrands added together. But now, let me just factor out x to the negative natural log of x over x. And then in the parentheses, I'm gonna be left with the arctangent of x plus the arctangent of 1 over x. Well, that's huge because arctangent of x plus arctangent of 1 over x, whenever x is a positive real number, is all equal to pi by 2. So that's gonna be just a constant there. I can take it out of the integral altogether and get that 2 times my I is equal to pi by 2, this integral from 0 to infinity of x to the negative natural log of x over x. That will make my I be equal to pi by 4 integral from 0 to infinity of x to the negative natural log of x over x dx. And now just make a u sub here. I mean, the log of x equal to u. That will make 1 over x dx be equal to du. You've got 1 over x there in the integrand already. Awesome. You'll get this integral becoming, the bounds become negative infinity and infinity of x to the negative u to du. That's x to the negative u squared du on the bounds of negative infinity and infinity. That's the Gaussian that I made at least 3 videos on already, which evaluates to the square root of pi. And so you'll get that I, the integral we were after here, is just pi by 4 times the square root of pi. So pi times the square root of pi by 4 is our answer. Hope you guys enjoyed it and see you in the next one.